if you look at this example, it says show that the linear system has infinitely many solutions. So remember, infinitely many solutions means that if you were to graph these two equations, every point on each of their lines would be a solution of both of them. So it means they have to represent the same line. So one way we could do this, again, would be put on a graph. So if I were to solve both of these from y, oops. So I do that by adding x to each side. And then I'll divide each side by 2. Two divided by 2 is 1y. Negative 2 divided by positive 2 is a negative 1. And then we have our 1/2 x. Okay. And let's do the same for our second equation. So I'll subtract 3x from each side. Don't forget that this is going to be a negative 6y. And then divide both sides by our negative 6. Negative 6 divided by negative 6 is 1y. 6 divided by negative 6 is going to be a negative 1. And then if I were to go keep, change here, I'd end up with a negative 3 divided by a negative 6, which reduces to a positive 1/2. Notice that these two equations are the exact same thing. If you were going to graph these, obviously on a graph you'd have your slope or y-intercept is -1, and your slope, is 1/2. So you're going to rise 1, run 2. Likewise, if you wanted to do the second one here, again, your y-intercept is a -1, and your slope is 1/2. So rise 1, run 2. And look, it is the exact same line. This means that there are infinitely many solutions. Every point on this line is going to be a solution to both of these equations. And what's interesting is when you look at them, you don't realize that they represent the same set of solutions because they look different. Another way you could do this, because remember we do have our 3 methods. This is graphing. Another way you can do it is linear combinations. Okay, so if you're looking at this and you can say, you know what, all I would have to do is maybe multiply the top number here by 3. Multiply actually both sides by 3. And the reason I want to do that is because then we're going to get a set of opposites here for your x's. So 3 times a -1x is a -3x. 3 times 2y is 6y, so plus 6y. Equals, and we have to remember always to multiply the other side by whatever multiplied the left side by. 3 times -2 is -6. And then we're going to combine that, our other equation, and look what happens. This is the linear combination method. My 3x's cancel out, my positive 6y and negative 6y cancel out, even everything over here cancels out. Basically, we're left with 0 equals 0. Now, that's a true statement. 0 is always going to equal 0. So, in this case, if you were to use linear combinations, you could see that it has infinitely, I can write here, many solutions. Infinitely. Because when we draw our lines like we did in the graph, they continue on forever in each direction. Okay? So to show that a linear system has infinitely many solutions, if you get a true statement like 0 equals 0, that's always going to be true, that shows that it has infinitely many solutions. If you were to write them in slope-intercept form and they come out to the exact same thing, that also shows that they have infinitely many solutions. So remember, most of the time we're going to be looking for one solution, but if in a case like this, this is showing that a system has infinitely many solutions.